So if you ever want to watch this, you can. So again, we're talking about Unit 1, lesson number 1, and we're talking about picturing distributions with graphs. And in fact, if we do pull up the syllabus is back here. It's also in Schoology, but I have it saved right there. Excuse me. Syllabus is on Introduction to Statistics and Charts and Graphs. So this is perfect. This is exactly what we want to talk about. And if we have some time at the end, we'll look at the textbook also, the electronic textbook. Okay, so going back to the PDF. So what is statistics? And so just so I give my voice a little break, we'll kind of go around the room. We'll have like, each person kind of read a portion of the notes. So Teddy, and I'm just going to go based on who I see below me in the screen here. So Teddy, would you like to read that first sentence about what is statistics?
Yeah. So what is statistics? A science that involves the extraction of information from numerical data obtained during an experiment or from a sample. Includes the design of the experiment or sampling procedure, the collection and analysis of the data, making inferences, statements about the population based on information in the sample.
Perfect, you stop there. So thank you, Teddy. Actually, now I want to show you one of the projects I've worked on. I apologize if you're not a sports fan, and I'm not trying to make this like a sports analytics class, even that would be fun, or I would enjoy that, but and maybe that might morph into that in a few years, who knows. But that is where my interest lies, and so just something that I've kind of done. I think I have it right here. Yeah, I think I just call it more simply football. There's my basketball analysis too. So anyway, so this is a little bit outdated. Yeah, I haven't used this file in a while, but it's just one that comes to mind. Or actually, do I have something a little more? No. Anyway, so this is year 2017. So these are NFL football teams. So you have like the Arizona Cardinals, the Atlanta Falcons. And you see that I have some data here. Like I collected how many games they played, how many points they scored, how many points they allowed, the point differential, total points they scored. Also looked at their turnovers. TO's abbreviated for turnover. How many times they're intercept. They throw an interception or fumble the ball, or this is all for offense, by the way. So obviously, how many times the offense is giving up the ball, and yards. How many yards the team gains. And so by collecting all the stats, so I had to collect it, right? And I do stuff with it. Like I was curious in finding, if you kind of look at the top here, the average points scored for NFL teams that season. There's another metric called the standard deviation. We're going to talk about that later today. And I try to glean some information from this. So this is an example of using statistics, right? And this is something I use actually when I'm making my football picks. So every week I make my football picks. I do it for a nominal amount of money. Fantasy football, I play that with some friends. But this kind of gives me a good feel for understanding, like that year the LA Rams were a pretty good team. The 49ers were okay, they weren't great that year. So that's an example of using statistics. Did I extract information? Absolutely. Is it numerical data? Absolutely. Did I get it from a sample or a population? Yeah, I got it from ESPN, and and am I trying to make inferences or statements about it? Sure. Like I'm trying to see okay, maybe some teams are better than others. I'm trying to understand why that is the case. So that's a great example of statistics. So Aidan, let me have you read the part about individuals and variables. So go ahead and read that part, please.
Okay. Individuals are the objects described by a set of data. They may be people, animals, or things. Variables are any characteristics of an individual. They can take different values for different individuals.
You can stop there. Perfect. So yeah, totally. That's exactly what I did, right? What are my individuals? These football teams. Those are my individuals. What are my variables? The number of games they played, the points they scored, their turnovers, their yardage. And so that's how we typically will look at our data. We need to have individuals and we need to have variables. Now the variables could be broken down in a couple manners. Ryan, do you want to read the parts about categorical and quantitative, please?
Yeah, categorical variables places an individual into one of several groups or categories.
And then quantitative.
Sorry, did I cut out?
You're good.
Okay. Quantitative numerical variables. Take numerical values for which arithmetic operations such as adding and averaging make sense, usually recorded in a unit of measurement.
Perfect. Now, the data I showed you guys is all quantitative. Every single thing here is quantitative, but there's another set of data which I need to kind of go to a different folder here. Give me one sec. Yeah, so this is an example of something that has some categorical. So like, for example, each row here represents a different basketball team and the date they played. This is October 17, 2017. And the venue, whether the team was on the road or playing at home, that is categorical data. There's no numbers here, but it's data I am interested in seeing. I'm curious, do road teams do better than home teams or vice versa? Is there a significant difference? But having that data is powerful for me because then I could work with it. But then how many points they scored, or maybe how many points they scored in like the first quarter, or how many 3-pointers they attempted, those are all quantitative data. And the quantitative data, obviously, I could do arithmetic operations. I could find the average. Or I could do something else with it. So that's something that we do have to consider. Or let me go back to the one about car insurance. That one might be a little more relevant because most people drive a car or are driven in a car. I think it was that one. Let's make sure I have the data set here. Yeah, I think it's the data set. Yeah, so like, for example, each row represents a different person who's being insured by a car insurance company. So let me ask this question. The income, is that categorical or is that quantitative? Someone could chime in.
Quantitative?
It's quantitative, it's numbers, exactly. The gender, is the gender categorical or quantitative?
Categorical.
Categorical, right. What type of education you have? What would that be? Are the numbers there, or is that categorical? Categorical, right?
Categorical.
Fully, yep. And so we can organize, depending on what we have, there's, we could choose what types of charts or graphs we're gonna use to display that information. Now, if I wanted to for income, I can make that categorical if I wanted to. I could like choose like, hey, anyone who makes over $200,000, I'll call that high income. Anyone who makes between $100,000 and $200,000, I'll call that middle income. Anyone who makes under $100,000, I'll make it low income. And then I can make categories if I wanted to. So you could do that also. And that's the other beautiful thing about statistics, is that you can choose to make quantitative categorical data. Categorical data, a little hard to make that quantitative. There are little tricks you can do, but depending on the type of data you have, that kind of tells us how we want to go about visualizing the data, like what types of charts we use. So let's talk about ways we can visualize our data. So I'll read this next part. Distribution of a variable. It tells us what a variable takes and how often it takes these values. It can be a graph, a table, or a function. So you can make an equation that you can put in a table. Like I've done it in a table, obviously. You've seen all my tables. You can make graphs out of them. Let me actually pull this up again. I don't know why I closed it. I should have left over from Tuesday. I think it was this file. This was a computer programming language. So this is a language R that I showed you guys on Tuesday. I'm going to open it up again. It's going to take a little while to go through the motions. and again, this is a language I will teach you guys later in the semester. I do have actually some good resources to help you with that. Okay, and again, it takes a little while to load when you're running Zoom. Actually, that's not the one. That's the one. There we go. So I first have to tell the program what directory I'm working with. So I'm working with this folder here. And you can see down below, it's kind of thinking until it recognizes, okay. And I don't know why there's an error. It was, let me try it one more time.
How do you keep this all organized?
I don't know. I'm just OCD about all this stuff. Okay, I don't know why this is now airing out. Or there's a warning. Okay, it was fine. Okay, we're okay. Yeah, I'm OCD with my organization, my Dropbox. I actually, to be honest with you, I think I could be more organized. I don't think I'm organized enough. Yeah. Anyway, that's the way my brain works. And then I have to hit this command. This command tells me to require reading an Excel file. So you can see it's loading it down here. And again, you know, I feel like if I just expose you guys to this, make you more familiar, once you actually start doing, you'll be more comfortable. And then this right here, I'm telling the program to read this file. So this is the file about quarterbacks. And I'm calling it data, so it stores it as a name. And that takes a little while because it has to kind of input all the, it has to read all the data and store it into this program here. So it takes a sweet little time. Yeah, I might have to do an update here because it's gonna. I tend to do a lot of this on actually my Mac device, if that's more up to date with these packages. But if you have a lot of data, this could take a while. You're probably better off using a CSV, which is called comma separated values, I think. CSV files are actually a little bit better because they don't take as much memory. But here I just got lazy and I just did it in a normal Excel file. So I'm just letting it read it. Python's another language some people may have heard of. If you've heard of Python, that is probably actually a more sophisticated language. We're not going to do that. That's just, I'm a little sketchy on that myself. I need to brush up on those skills. But that's when people talk about big data, they're talking about crazy, crazy amounts of data. Typically, they're going to be using Python and a more powerful computer to read that. But you know, we're not doing that here. And of course, if I want to see a summary of my data, you know, it kind of tells me all the different variables here. And actually, if I were to pull that open, let's see. Yeah, if I were to actually open up that file. So here you can see each row represents an NFL team from a different week. Actually, sorry, these are NFL players, my bad. Each row represents an NFL player. So if we think about it, Tom Brady, his team is New England. So the team, is a team categorical or quantitative? Categorical, right? There are no numbers there. But how many points his team scored, that's quantitative. Or how many rushing yards he got, that's quantitative. Or whether he was home or away, that's going back to categorical. Anyway, but let's show you the data visuals. So I run this line of code to kind of tell me I'm going to do a 3x2 grid. So it sets up a 3x2 grid. And then I could just run all 6 of these lines at once and focus on the right side. So it's taking a little while to process. I don't know, I didn't process all of them. Close that. Huh. Oh, because I'm an idiot. I was supposed to actually run this code. There we go. Let me go and clear this. Okay. Now let me actually run this again. So I can actually run all this at once. So you generate all these plots here. So this is what we're going to be talking about today. The ones off to the left are all histograms. The one off to the right are all called box plots. Now, as you can see, this is for fantasy sports. There are two big websites that do that, DraftKings and FanDuel. So those are games I like to play. I think they're fun. I find it fascinating. But this is something I use to actually, make my picks. And I use this to analyze how I go about making my picks. So you can see I'm looking at like a histogram of points, but it's also decided to do things a little differently. I think I did like a logarithm of the points or the salaries. So again, this is kind of just a way you can visualize your data. So obviously points are quantitative. I'm using a histogram or a box plot to show that. And that's what we're going to talk about next. So let's talk about display and distribution. So Zach, go ahead and read the part about display and distributions and the stuff below.
Sorry, the distribution variable?
Display and distributions.
Oh, okay. Choose an appropriate display given the variable you're trying to illustrate. Categorical variables. Continue.
Sure. Mm-hmm.
They'll list the categories and give either a count or percent of individuals who fall in each category using a pie chart or bar graph. And then quantitative variables show what values the variable takes and how often it takes them, sometimes grouping nearby values using histograms and stem plots. Great.
So here's another, so I'm going to now go away from sports. I'm going to talk about something a little more practical and relevant. Close that too. Close that. Actually, I want to keep that open as for NBA today. Won't close that one. But let me show you a project that I did for Sacred Heart. So for the last 2 years, I was only teaching part-time. I was 2 years ago, I taught only 2 algebra 2 classes. Last year, I taught 2 algebra 2 classes. So I was doing a lot of, my other role for the school was I was doing a lot of data work and data analysis. And one project that I was tasked with was to survey all of our employees and ask them about their living conditions. So I want to know, hey, do you rent your house or you own your house? How far do you live from your house? I want to, how old, I mean, I can figure out how old they are from HR, from human resources, but save myself trouble. Are you married or not married? Do you have kids? You don't have kids. If you rent, how much are you paying in rent? Has your rent gone up every year for the last 5 years? If you own, what is your mortgage like? So we collected all this data because we were kind of curious to know, what are some of the hardships people are dealing with, what the school can do to kind of alleviate those hardships. To me, this is the project I took probably the greatest pride in because it really kind of helped the school kind of retain employees, because a lot of people tend to leave Sacred Heart or just leave California altogether because they find this is a very expensive state to live in, right? So we're trying to figure out, try to understand what our employees are going through. So,
Mr. Lemke, I have a question.
Yeah, go ahead.
So how is it that you, I guess, gather the data for all these subcategories? Do you rent or do you buy, or what's your mortgage? What's your does that make sense?
Yeah, we did a survey.
Oh, okay.
Yeah, so we surveyed. Yeah, so that data, obviously, I have to design a survey. And so that's the other thing that we're going to do in this class also is how do you make good surveys? How do you ask questions not biased? This is actually going to be especially important going to an election year because a lot of surveys you see regarding election can be skewed or biased. But bottom line is I was just trying to collect data. So that's what I did. So we actually had all the employees after winter break. We always have Director's Day, and we just collected the data then. But things that are like for finance or sports, yeah, I mean, I could just go to some website and locate it. But that's always kind of I would say that's probably one of the biggest challenges. I think the analyzing part's the fun part. The more frustrating part could be finding good data that's reliable and also cleaning it up so it's organized. That's but I'm going to make it easy. I'm going to give you guys at least for this semester, I'll give you guys clean data. I'll give you guys data that's easy to work with. Second semester, I'm not going to do that. Second semester, when you're working on a project, I'm going to teach you guys how to find good data and how to actually clean it up, and how actually you can use a program like R here to clean your data for you. So that actually, I would say is probably a bigger task than anything else. So let's look at this one. This is called the retention survey. And this data is somewhat confidential, so don't really share it to many people. I know actually a few of you have parents who are administrators, so just keep this to yourself. But anyway, let me show you the presentation here. So this right here is a pie chart, right? What is a pie chart representing? If you look off to the left, it's looking at years of service at Sacred Heart School. So I put this as categories. Even though years of service could be quantitative, I designed it as a category. Are you new to the school? 45% of our employees are new to the school. Are you kind of new to the school? About 24%. I'm in this category. I'm in the, actually no, I'm now in the blue because I've been, that's my 16th year. So I'm in this category right here. Marital status. Are you single? Are you married? Obviously, I'm in the married category. Some people are separate. Some people are divorced. Some people are widowed. But we were kind of curious to get a snapshot. So by seeing this, without actually, I could do the numbers, but this actually is kind of better because then I look at this like, we got a lot of new employees at the school here. Okay, a lot of people are married here. So a lot of people are probably middle aged like me. And then also I kind of broke it down a little further. Hey, what's the average household size? That's quantitative. Hey, it's 3 people, probably man, wife, and a kid or something. I don't know. 5, 6 employees. That was more data I collected. They're the prime provider of benefits. So kind of gives you a good example here. This right here is what we call a histogram. So you can see I have like 6 categories here. The categories are how long does it take you to drive to school? Some people live very close. Some people live very far. It's round trip, mind you. And again, by looking at this, you're like, oh, wow. People are sitting in the car a long time to get here. Not the case anymore because we're remote. And if you drive, there's not really many cars on the road anymore because a lot of people are working from home, right? But that's also another way you can visualize your data. Here you see another pie chart. Owning and renting. This is categorical, right? Whether you own or rent. This right here, I turned the categorical, but it could be numerical or quantitative because we could actually look at the number of minutes that people spend driving to work. Here's yet another more data. This is pie charts again. And here I'm asking how many times your rent increased. And if you look at this, it's pretty sad. I mean, 85% of our employees have had their rent increased. This is, again, this for the employees who are renters. If you look back over here, half our employees rent, half our employees own. But for employees who are renters, their monthly rental expenses increased at least once in the last, well, 85% in the last 5 years, but still 2/3 in the last 12 months. So that's scary because what if your salary doesn't go up, but your rent goes up? Then all of a sudden you have to make a concession somewhere. Maybe you have to go get another job, or maybe your spouse is home taking care of the kids. Now, your spouse has to work, and you have to pay for childcare. So it's kind of interesting stuff. This one's a little confusing. I'm actually going to skip that one. So here we see back to histograms again, or bar charts. So we're looking at like, so this one is, would you stay at Sacred Heart? Or would you sign a 3-year commitment? Okay, this part is a little more confidential. Sure, I shouldn't share this, but we were curious, like, would people sign a 3-year commitment if they got the benefits they were looking for? And what are the benefits people were looking for? More money for housing, maybe a loan for a down payment, maybe more contribution to their retirement plan. But see, this is all statistics and machine learning. Machine learning stuff, this is actually a little bit confusing. I'm not going to get into that just yet. But again, like, we look at more data, right? Like, and so I call this prescriptive analytics. So here I was prescribing to our administration, to our board, hey, what do we need to do to keep our employees here? Maybe we need to buy a piece of property. Maybe we need to do a master lease or stuff like that. But you can see how I'm visualizing the data, using bar charts or pie graphs. So it's a great way to kind of understand what you're working with. And very relevant. I mean, actually, that's what I do as a career. I do this work for the school. They pay me to do this. And I went to school to learn how to do this. I decided to get another degree. So it's all good stuff. So we're going to look at these types of graphs in just a little bit. So histograms. So moving right along. So choose the classes. So first of all, you have to kind of figure out, hold on, let me see what's going on here. Okay, what's meant by this is choosing the categories. But let's talk about what our data is first. How about that? Before we get too carried away. What is the data we're dealing with? We're dealing with weight, right? And then we need, I'll call it categories. Does anyone follow like boxing or MMA? Not so much. Well, how do they categorize boxers? Does anyone know? Or fighters? By weight class, right? They call it a class. And so there's a heavyweight class, there's a middleweight class, there's a flyweight, bantamweight. Personally, it gets very confusing. I'm not a big fan of that sport, but how many individuals do you think we have here? If you were to kind of do a quick count, how many individuals, how many people were surveyed here? Because remember, we collected their the weight of the incoming freshmen. Does anyone want to chime in?
53.
We have 53 individuals. So the rule of thumb is usually you can square root the sample size and round up. So let's actually take the square root of 53. Which is 7.28. And we'll round up. So we'll do 8 classes or 8 categories. Okay. Then the next thing you probably want to do is you probably want to, find the range, the max minus the min, and then divide by the number of categories we have. So what do you think the lowest data point is here? Who is the lightest person in this class?
100.
Who's the heaviest?
260.
Great. Did not come up very nicely. So your class width, or we'll call it the category width, (260 minus 100) divided by 8. So it's 160 divided by 8. So each width is going to be 20. So what we're going to do is we're going to do 8 categories. 100 to 119, 120 to 139, 140 to 159. You kind of get the point what I'm trying to do here. 160. I'm not going exactly by 20 because I don't want to overlap. I don't want to do like 100 to 120 and 120 to 140 because then what do you do about someone who's 120 pounds? So I'm just trying to be a little more discreet here. 180 to 199, 200 to 219, 220 to 239, and we'll say 240 to 260. So I create 8 categories. Now what we need to do, this part could be a little painful, is count. how many people belong to each category. Notice that my data is not in numerical order. I do not advise you to kind of search and kind of count. That's not the best way to do this. So here's what we'll do instead. This is the beauty about using Excel. Using R would be actually a little better, but that's okay. So I actually have this saved as a Word document. Well, isn't that lovely? Okay. So, well, that's an epic fail. Great. I was hoping that was just lists so I could just copy and paste it. So here's what we'll do. We'll just count for one of them, but we're not going to do it for all of them. It'll just take too long. That's okay. So if I kind of look back up again, how many would belong to the first category? How many of these data points? How many are between 100 and 119? Again, I don't advise you to do this in real life. It's not terribly efficient. But we're kind of committed to working this data now.
7.
Yeah, I counted 7 also. So you're going to put 7. Then we have to count all the other ones. We'll just do it one more time. Let's do it for 120 to 139. So if we go through our data, let's count all the ones that fit from 120 to 139.
$11.
You guys are definitely ahead of me. I will definitely agree with you guys. 5, 6, 7, 8, 9, 10, 11.
No,
Good.
12.
Yep. Was it 12?
I think it's 12. I missed one.
Maybe I missed one too. I believe you. We'll just say it's 12. So anyway, so you get the point here. So then what happens is that, okay, fine. There are 12 people. And just because I don't feel like counting all these, I'm just going to kind of make up some of those other ones here. We'll just make them up. I have to make sure this all adds up correctly, so give me one sec here. Okay. So I just made those up. But I know you guys can actually count, so not worry about that. So what you do, when you do a histogram, is you make your categories. Just like you did, just like I showed you in that project I did for Sacred Heart. So this would be your first category, 100 to 119. This would be your next category, 120 to 139. You have all the other categories here. So this would be reserved for your categories. So we're doing a histogram. And then we look at the frequency.
Mr.
So
Almaty,
go ahead.
what's the difference between a histogram and a bar graph?
So actually, they're the same thing. They're not really that much different. A bar graph can actually be, so actually technically I am doing a bar graph, to be honest with you. A histogram is more when you're looking at, if I'm looking at test scores, for example, So actually, let me pull this up again. That might be a little more helpful. Well, histogram tends to deal more with numbers, I guess. That's maybe a better way of putting it. So you can see here, like I was looking at like number of points that these players are scoring. If you look at this one in the middle here, from 65 to 90, they're still in categories somewhat, but what this program did, it kind of told me who fit in each of these different categories here. A bar plot is if you're not necessarily dealing with numbers, I guess. Like, for example, let me go back to this slide deck here. This is more of a bar plot. So like, if we looked at like owners versus renters, right? If you owned or rented a house, would you sign through your agreement? So there's really not really numbers. Those are categories as the x-axis. So that's technically a bar plot. When you're dealing with numbers, that's technically a histogram. So that's it's very subtle, but that's what I'm saying. They're not really that much different. And sometimes those terms are used interchangeably. So I'm not going to really be too bent on that. What I do care about is that you do visualize your data correctly. That's what I do care about. But we are talking about semantics a little bit. So, but I did break this down in categories. So I guess technically I'm doing a histogram. But frequency, let's say that's 5 and that's 10.
Mr. Malashny, I did the counting.
Oh, you did all of it? Okay.
Yeah.
So were my guesses off?
Yeah, by a little bit.
Okay, that's okay. We'll just go with what we have here. Well, actually, why don't you tell us what do you get for the second category, for the third category?
7.
Oh, the next one.
9.
Keep going.
12. 4. 1. 1.
Okay. And were the first two correct?
Yeah.
Okay. So then, as I do the other categories, they're going to kind of look like this. And the fifth category will be a little higher. Then the next one will be much lower. And the next two are very low. So this kind of shows me how this is distributed, that we don't really have too many data points near the far. So there's not too many people who are very heavy. There's some people who are pretty light, but majority of our people are kind of in this weight range. So that's the advantage of having a histogram. It kind of tells us what we kind of expect of our data. And again, could I call this a bar plot? I guess you could, because we did break into categories, but since you're dealing with like quantitative variables, we tend to call that a histogram. Again, it's kind of semantics with like the terminology. So that's basically how you draw it. The variable you're studying goes on the horizontal axis. We're studying weight classes. The count, we counted how many were in each class, and we drew bars. So we totally did this. And we did make a frequency table. So we've now made our first histogram. So that's how you do a histogram. Oh, no problem. Go ahead. Okay, now let's talk about a stem plot. And this will kind of take us to the end of this lesson. And maybe we don't quite get into lesson 2. Maybe lesson 2 I'll do as an asynchronous lesson for you guys to watch over the weekend. Then we can have that discussion on Tuesday. So let's talk about stem plots. Stem plots are kind of neat. They're very old-fashioned. Believe it or not, they do actually sometimes cover this on the SAT and the ACT. There's been a lot of news recently about the cancellation, and now there's a judge in Alameda County who ruled that it's illegal for the UCs to even look at the scores, even if it's optional. Like they can't just look, they can no longer look at them. Which I'm like, oh boy, what are the colleges supposed to look at now? Because they don't have letters of rec for UCs, right? and a lot of people have pass-fail grades in public school. So I don't know what's going on. This is a crazy world we're living in, but just make sure your personal statements are really good. Put it that way. I don't know what else to tell you guys for those who are applying to college. Or just just be happy you get in somewhere for college and you'll love it. Yeah, weird times we're in for sure. Okay, so let's do a STEM weight plot. So if we read the instructions here, this is a little confusing, but I'll have you guys help me with the reading. Mel, do you want to read number 1 here for me, please?
Yeah. Separate each observation into a stem consisting of all but the final, rightmost, digi, and a leaf. The final, is that supposed to be digit? That's
Digit, yeah.
Okay. Digit and a leaf. The final digit. Stems may have as many digits as needed, but each leaf contains only a single digit.
So here's how it's going to look. We'll come back up here again. So you're going to draw a line. We call this a stem. That's stem. We call this leaf. So our lowest data point was 100. Our highest data point was 260. So what I'm going to do for the number 100, there are 3 digits there, right? I'm going to put a 1 and a 0 and then another 0. So that's how I would write that. Now, what's the next number that shows up after 100? What's the next highest number after 100? If you look at the data carefully.
101.
101. So now what I'm going to do is I'm going to put a 1 here. So what this actually represents 2 numbers. The stem for both numbers is 100. Sorry, the stem for both numbers is 1 and 0. So you have a 100th digit and you have a 10th digit. And then you have 100 and 101. So that represents 2 numbers. Are there any other weight class or weight values that would fit under this stem here? Like, what's the next highest after 101?
$106.
Yep. So I'm going to put a 6 here. So now this is representing 3 numbers, this first row, 100, 101, and 106. So going back here, you write the stems in vertical columns with the smallest on top, and then draw a vertical line, which I did at the right of the column. And then you write each leaf in the row to the right of its stem in increasing order out of the stem. So now let's look at those that are beginning with 1, 1, 1, 1. So now we're looking at the Now we're looking at the 110s. So there's definitely a 110. And I can cross off the ones I've already done so I don't have to do it again. So here's
one to your left.
Yeah, there's another 110, right? So you do that again. And then is there like a 1?
19.
Oh, there's 2 106s. I didn't see that. Okay, 110, is there a 111 or a 112? That's what you should have as numerical order, mind you. It's kind of weak that it wasn't done that way. Maybe it makes you appreciate when it actually is in order. I guess you have that. And then you kind of just keep going. Until we get to the end. And what you're hoping to see, like for example, I think there's a bunch of numbers in the 150s or 160s.
120.
How many are in the 120s? There's definitely a 120.
7.
Okay. What was the next? There's another 120.
There's 2 120s, a 123, 124, 125, 127, 128.
So you see how this visualizes our data. Now we see that, oh, wow, there are a lot of numbers in that row. But then the 260s, I think we just see one. Like if we did the 250s,
So what if there's no 250s?
then you just show nothing.
Yeah.
There's nothing there. 240, there are no
There's some low
240s.
240s.
230s. So the bottom line is you kind of see if you kind of tilt your head, you can kind of see there's a distribution. Or if you rotate this 90 degrees counterclockwise, you can kind of see that there's a distribution there. And we tend to see most of our data in this region right there. So that's kind of why we have these stem leaf plots. I won't have you guys write it all out, but it just takes a while. But that's how you do a stem leaf plot. And if we go to the online textbook, charts and graphs, and talk about quantitative data graphs, so histograms are mentioned right here. Other types of graphs they could do. Then they talk about stem plots. Stem leaf plots.
Dots.
What was that? Sorry.
What was the one with the dots? Like I think it's a little bit above. Right
Dot plots.
Oh,
It's
that's
the
fun.
same thing as histogram. Yeah. No different. You can do dot plots. By the way, did anyone have any trouble purchasing the book or accessing it?
I had a little trouble, but I figured it out.
Okay. Now there's this thing called Wiley Plus, where you actually where you can watch videos. Does anyone have access to that? Or no? Like the lecture videos?
I heard about it from our Spanish teacher, but I don't think we got it.
Okay, let me look into that a little more, because those are actually going to be pretty helpful. Like, so you can see here this guy, his name's Ken Black.
Hi, I'm Ken Black.
And he gives like really good descriptions of all these things. So let me do a little digging and see how we can get you guys access to that.
23. Then for the
I mean, I could technically record him talking on a Zoom call, but that's kind of a copyright situation that I want to be really careful about. You did purchase the book though, so we are giving him money. So let me look into that, because I would like you to have watched his videos are done really, really well, and he explains these things in a great way. But you can see that that's another example of all that stuff. Now, qualitative data graphs, pie charts. We talk about how to do pie charts, and we need to do with pie charts. Like for example, here we're talking about the top 5 petroleum companies: ExxonMobil, Valero, Chevron, ConocoPhillips, and Marathon Oil. And these are barrels per day of their capacity. So we kind of add them up, like figure, okay, all 5 of these companies produce this many barrels of oil per day, or maybe they refine whatever. I don't know exactly what's going on here, but then we have to look at the percentage that you can attribute to each of those companies. So ExxonMobil does 37%, Valero does about 18.35%, and these other ones a little bit lower. And then for a pie chart, because a full circle is 360 degrees, what's happening here is that each is being multiplied by 360. So now you know why we spend all this time having to talk about circles. So you can do pie charts. Now you know how many degrees to attribute to each of these portions of the pie chart. Then you actually could draw the pie chart like that. Now, Excel actually does this very quickly. If you put in the data and you actually know some of the features, it'll spit this out for you really fast. But then you can like format it, you can change the colors, you can have labels. That's why I want you guys to know how to use Excel, because we're gonna be doing this kind of stuff down the road. So right now we're just doing the nuts and bolts, but we are gonna come back to this and you are gonna actually do this stuff. There are also stuff when you have like two variables, but those are dealing with scatter plots. We're not there today. We're not gonna do that yet. And we're done in about 9 minutes anyway. It's going back to the worksheet again. Let me go ahead and clear all this. Okay. So examine distribution of quantitative data. You want to look at the overall pattern of graphs. That's always very important. Do any deviate from the overall pattern? The shape of the data, sometimes that matters. The center of the data, that kind of matters. How spread out the data might be. Outliers is kind of a big one. And then time plots. Time is typically done on the horizontal axis. Whatever you're measuring is on the vertical axis. You try to look for overall patterns and any deviation from the trends. And maybe look for patterns that repeat at known regular intervals or seasonal variations, stuff like that. So let's actually try and think what's let's go back to its electronic textbook again. Actually, I'm gonna jump around a little bit here. Give me 1 second. Let me just locate this right now. Give me 1 second here. I'm going to show you guys an example of an outlier. We'll wrap it up for today. Okay, I found what I needed. So I'm gonna share my screen again. We're still recording. So we want to talk about the overall patterns of data, right? I'm afraid I might turn everyone here into a sports fan eventually. Let's talk about the San Francisco Giants. Even if you watch local news, maybe you heard of this, of what happened. So 2 days ago, why is this unusual? Does anyone want to share? What is unusual about this? How many runs did the Giants score?
23.
How many did the other team score?
5.
That's very unusual. Baseball's rarely that kind of score. These are more typical baseball scores. As you see up here, these teams are playing right now. So we consider it to be an outlier. It's kind of out of the ordinary. We don't expect that to happen. It's an extreme value. Now, why did the Giants do so well? Well, there's one guy, not really the best player, but he's doing okay. His name is Alex Dickerson. He apparently had 3 home runs that day. And he had, I think, 2 doubles and lots of RBIs. And if you were to click on him and click on his stats, he's not like typically the most feared hitter. Like, doesn't have that many. He had half his home run total all in one game for the season so far. Now, this right here is a distribution of, we call it his fantasy points. Like, so some people play fantasy baseball where they actually try to, they have a formula to figure out how many points this person scored. So you look at this distribution, it seems that most of the data is over here somewhere. But look at this little blip over here. Where do you think that came from? 2 days ago. That came from 2 days ago. Do we expect him to do that well all the time? No, because where's most of the data? Over here. So that's why it's nice to have data visuals. Now, this is a different kind of plot. We'll talk about this kind of plot much later in the year. This is what we call more of like a cumulative density or probability plot. We'll get to that in a while. But and my hope is to teach you guys how to do this kind of stuff. But that's an outlier. We don't expect that to happen. Another thing about have any of you guys heard of this book called Outliers? Maybe I might make that required reading. We'll see. So if you haven't heard of it, it's okay. I read this book many years ago, and if you look at the subtitle, The Story of Success, so Malcolm Gladwell kind of talks about what makes certain things really stand out. And so he talked about like Silicon Valley, for example. Like, why is there like there's some people who just make just ridiculous amounts of money or like are so wealthy? What was special or unique about them? Because a lot of people don't make billions of dollars, but apparently a lot of billionaires live here in the Bay Area. Or another one he kind of focused on was like hockey players, and that's kind of because he's Canadian. He kind of was curious, like, what was it about hockey players that made some hockey players better than others? He actually discovered that hockey players that are born in January tend to do pretty well. That's mainly because that's usually when the hockey season starts in Canada, the junior hockey leagues. And if you're like 9 years old and you turn 9 in January, or actually, yeah, I guess if you turn 9 and the rest of the kids are all 8 years old. I can't remember. It was something about those who were born in January were about 11 months older or 10 months older than all the other kids. So naturally, they were bigger and faster than the other kids. Because I bet you a 6-year-old is probably gonna be a little stronger than a 5-year-old, right? And so ultimately, they just got better because they're always considered like one of the better players. So that's something he found. And with going back to Silicon Valley, he found that a lot of wealthy, at the time he wrote this book was, I think, the year 2010 or so. He discovered a lot of these guys were in their mid-50s, like Bill Gates, Mark Zuckerberg, not quite, but Larry Ellison, Steve Jobs obviously passed away, Paul Allen, who also passed away. But he found that a lot of these guys were in their mid-30s in the mid-90s. Now, what was going on in the mid-90s? There was a dot-com boom. When you're in your mid-30s, you're probably a little more willing to take some risks. Also, you have some money you can work with because you've actually been working the work world. Myself, personally, I was only 18 years old. My dad was in his 50s, not going to be willing to take those kind of risks. So he found that the age kind of mattered. that these people were kind of like in the right time and kind of were fortunate. So it's kind of interesting when you start trying to dig a little deeper and try to understand like why these certain data points, like why did that guy Alex Dixon hit 3 home runs that day? I don't know. Who knows? I mean, maybe it's just dumb luck, or maybe there's.
We ended class.
Yeah, we're ending right now. Yeah.
Okay. I just was making sure.
No worries. Yeah. I know.
Sorry.
But anyway,
I don't mean to be like that.
but we're going to talk about outliers too. So today we focused on making stem plots and histograms. So I'll probably have, well, most likely do is I'll sign for homework some stuff from the electronic textbook on just histograms and reading stem plots. I think that's just some skills you guys need. And then I'll make a video on lesson 2 for you guys to watch. So just pay attention to the homework. I'll put it in Schoology by tomorrow. And I think we're all set. All right, I'll let you guys take a little break, and you have your last class, and I have my last class to teach as well. All right, I'll see you
Mr.
guys later.
Mashi, can I just ask you a real quick question?
Yeah, go ahead. And I'll stop.